Hello, in today's video I'm going to be creating a simple PLC program that will simulate a traffic light. I will be using Connected Component Workbench and the Allen Bradley Micro 850 simulator. First, I like to start off by listing out my events of showing what my program is going to do. And as you can see here, initially I will have the red light on, and then I will wait about 15 seconds. Then I would turn off the red light, and then the green light will turn on for about 15 seconds. The green light will then turn off, and then the yellow light will turn on for about 10 seconds, and then it will turn off, and then the red light will be on again. So after I'm done listing out the events, I like to list out my digital inputs and my digital outputs and any internal bits and timers that I'll be using. For this example, I'm not using any digital inputs. I'm only using digital outputs and these timers, because this is going to be a timer based application, which I'm not going to be requiring any type of digital inputs like a button or a sensor to activate the status of these lights. Now I've opened up CCW and I'm about ready to create a new file, and I'm going to call this light or traffic light application YouTube. Hit create. Then I'm going to go to controllers and I'm going to select the 2080-LC50-48QWB-SIM. SIM. That stands for the simulator. And if you have this and you just want to simulate it, this is what you have to click on. And then I'm going to add to project. Okay, so the next step is to go to configure drivers, and this window should pop up. In this example, this has already been selected, but if you were to configure it, you go here and you got the IP address right here. And because it's a simulator, it's trying to simulate as though it was a real PLC. So make sure that this matches up with the simulator. Then I'm going to create my programs. I'm going to do ladder logic for this example. And I'm going to change the name here for the main program. Call it main program. And that's going to be the main program that we're working off of. Then I'm going to create another one, and I'm going to call this one digital outputs. Looks like I didn't like that one, so let me try it again. Puts. There we go. Alright, so here are the two subprograms I've created for this application. Okay, so now I'm going to start filling in the global variables, and I'm going to grab those from the Excel spreadsheet that I created, and I'm just going to copy the alias into here like this. As you can see here, I have all the hard outputs with their aliases corresponding to the red light, the yellow light, and the green light. Next, I'm going to start entering the internal bits, which I'm using the same tab as the global variables. Scroll down here, enter those here. Now I gotta name the variables here, and I've already have the name right here. This is just for my bits, because we're going to be using these bits throughout the entire program. So that's why they're going to be global variables. And there you go. So we have a bit for the green light, an internal bit for the red light, an internal bit for the yellow light, as well as a reset bit, which once we get into the actual program, you'll see what each one of those bits will do. Okay, so now I'm going to go and start creating my program. I'm going to go with the digital outputs. Then I'm going to start creating it. This is going to be very straightforward. It's just literally the bits are just triggering on and off the outputs. So I'm going to put some normally open contacts there. Go to my global variables. I'm going to start off with the green light. And I'm going to start adding the rungs. One for the green light, and one for the yellow light. I probably won't do one for the reset. And another one for the yellow light here. Now we're going to enter the coils here. And we're going to go with the system variables, or the I/O. And as you can see, I'm going to make them correspond. So these are the actual, before I begin, these are the actual hard physical addresses for the actual outputs on the PLC. So I'm going to correspond each one of those to these input bits. Green, red, and yellow. And there you go. Now we got about a quarter of this finished. Now we go to the main program. Okay, so I'm going to start off by going and putting in the red light, and I'm going to use the red light bit that we set up earlier in the digital outputs. So that will be triggering the physical output here. So first of all, before I start placing normally closed contacts, what must be true when the red light is on, because it's going to initially be on from the get-go. We know that the yellow light cannot be on, so we're going to make that a non-energized bit. And we know that the green light can't be on at the same time as the red light. And this is the first rung. So we have this first rung here. So this should just automatically turn on our red light. But eventually we want this red light to change states based on the timer. So we're going to create an extra rung. And we're going to put the green light on this rung. And then we're going to put a timer, and I'm going to do it like a timer on. Drag that there. And there's got to be certain conditions for this timer to start its timing. But first we want to establish what our preset timer is going to be, and we said 15 seconds on that Excel spreadsheet. Okay, now we got to consider the conditions this timer is going to be turning on in order to turn on this green light. So first thing we know is there's a reset bit, and that reset bit cannot be energized to turn on this timer. We also know that the yellow light cannot be energized during this time. The starting condition for this timer means that these two cannot be energized in order for the green light to turn on after its 15-second countdown. Okay, so now we got to add a third rung, and this is going to be the conditions for turning on the yellow light, but it's going to be the timer for the green light. So we'll put the yellow light coil here, or bit, and we'll put in another timer. Then we're going to set that up, and that's going to be 15 seconds. Then we got to set up the conditions for this timer to start counting down. Oops, it looks like I forgot to put the T in front of that. Let me do that. Thought something didn't look right there. Okay, so same with this one. Alright, so both of those are now correct. Now what I'm going to do is I'm going to start putting in the conditions, and for this to be true, or for this timer to be activated, the red light must not be on, and also a reset button. So we'll add those in. Now we add the fourth rung, and we put in the reset. Now we're going to actually use this reset. Then what we're going to do is we're going to put another timer. Here. And this reset's going to reset everything back, so it'll just go back to the red light. And it would also, this timer right here would be the timer for the yellow light. And we established that that was going to be at 10 seconds. And the conditions have to be that the yellow light has to be on in order to trigger this. And then over here we'll have the reset bit cannot be on. And then we're going to also make sure that these two timers do not affect this timer, so these cannot be on. And there you can see we've got timer 2 and timer 3. Also remember that this is very specific, so you can't just press that. You need to actually have the Q, which is the output. Going back to local variables, and you go here. Nope, sorry. Go here. Then that's for 2, and now we need one for 3. And there you go. You've got both of them on here, and that's just to make sure that these two do not interfere with this counter or this timer. Now comes the fun part where we get to test out this program. So what we're going to do is we're going to go to our simulator, and you want to make sure that this is on, and make sure that it's selected to program, because that's what we're going to be doing to it. Then we're going to do a connect. Now we got to look for our device, and this is the one that we want. Select it, and now we're going to connect to it. Okay, so now it's telling us to, or asking us if we want to download, and so we're going to download it. This is the program we just created. Download. Okay. So go here. Usually these start lighting up to kind of show that it's ready to start the program. And it's succeeded, so that means we had no errors, which is good. That means we wrote our program correctly. No syntax errors. And our download has succeeded, so let's... now it's ready to be run. So we hit the button for run. And as you can see here, this is our red light, and it's stepping us through. Pretty sure our green light's going to be on, and that should be shutting off the red light, which it does. And now that's running, so we should be getting the yellow light pretty shortly here. Green light. Now the yellow light. And it's going to go back to the red light after the 10 seconds. Let's see if that matches up with what we have here. Or it should match up with what we have here. So that's our 0, 0. That's the 0, 0, 2, so that's our green light. And there's our yellow light, 0, 1. And there you go. Now this is just how I wrote this program. I know there's probably other ways and possibly even better ways of writing this. This is just how I approached it. If you have any questions or things I should probably look into for this program or for this example, just drop me a message in the comment section below. And please subscribe to my channel so I can start creating more content like this and hopefully get better at it. Thank you. Bye-bye.